6 powerful functions of a bridge rectifier. Bridge rectifiers are essential components in converting alternating current, AC, to direct current, DC, in various electronic circuits and power supplies. Here are 6 powerful functions of a bridge rectifier. AC to DC conversion refers to the process of converting alternating current, AC, electrical power into direct current, DC, electrical power. This conversion is essential for many electronic devices and systems that require a steady DC voltage or current to operate. The conversion process involves rectifying the AC waveform, which alternates between positive and negative cycles, into a unidirectional flow of current. This is typically achieved using rectifier circuits, with bridge rectifiers being one of the most common configurations. In a bridge rectifier circuit, 4 diodes are arranged in a bridge configuration, hence the name. The AC input is applied across 2 diagonally opposite corners of the bridge, while the DC output is taken from the other 2 corners. This arrangement allows the rectifier to utilize both halves of the AC waveform, resulting in a more efficient conversion compared to half-wave rectifiers. During the positive half cycle of the AC input, the diodes conduct and allow current to flow through the load in one direction, producing a positive voltage at the output. During the negative half cycle, the diodes conduct in the opposite direction, again allowing current to flow through the load, but in the same direction as before, resulting in a positive voltage at the output. As a result, the output voltage is a pulsating DC waveform with less ripple compared to half-wave rectification. After rectification, additional filtering may be employed using capacitors or inductors to smooth out the pulsating DC waveform and reduce ripple, resulting in a more stable DC output suitable for powering electronic devices and systems. Overall, AC to DC conversion is a fundamental process in electronics, enabling the operation of a wide range of devices and systems that require DC power for their functioning. Efficient rectification refers to the process of converting alternating current, AC, into direct current, DC, with minimal losses and maximum effectiveness. In the context of bridge rectifiers, efficiency is crucial for ensuring that the converted DC output closely resembles the desired waveform with minimal distortion and ripple. Here are some key factors contributing to efficient rectification in bridge rectifiers. Utilization of both AC half cycles. Bridge rectifiers utilize both halves of the AC input waveform, unlike half-wave rectifiers, which only use one half. This allows for more efficient conversion of AC to DC, resulting in a higher average output voltage and reduced ripple. Low forward voltage drop. Diodes used in bridge rectifiers should have low forward voltage drop characteristics to minimize power losses during conduction. Modern semiconductor diodes, such as Schottky diodes or ultra-fast recovery diodes, are often employed for their low forward voltage drop and fast switching characteristics. High reverse voltage rating. The diodes in a bridge rectifier must withstand the reverse voltage present during the negative half cycle of the AC input. Choosing diodes with a sufficiently high reverse voltage rating ensures reliability and prevents breakdown or damage. Efficient heat dissipation. Efficient heat dissipation is essential to prevent overheating of the diodes and other components in the rectifier circuit. Proper thermal management, such as using heat sinks or thermal pads, helps dissipate heat generated during operation, improving overall efficiency and reliability. Optimized filtering. Additional filtering components, such as capacitors and inductors, are often employed to smooth out the pulsating DC output and reduce ripple. Optimizing the filter design helps improve the efficiency of the rectifier by minimizing energy losses and ensuring a stable DC output voltage. Minimal conduction losses. Conduction losses occur when the diodes are conducting current during the forward bias state. Minimizing these losses through careful selection of diode characteristics and operating conditions enhances the overall efficiency of the rectifier. By considering these factors and optimizing the design and components used in the bridge rectifier circuit, engineers can achieve efficient rectification with minimal power losses and high performance, making bridge rectifiers a preferred choice for various AC to DC conversion applications. The compact design of bridge rectifiers is advantageous for various applications where space constraints are a concern. Here's how the compact design of bridge rectifiers contributes to their efficiency and versatility. Integration of components. Bridge rectifiers consist of 4 diodes arranged in a specific configuration, typically in a compact package. This integration of multiple diodes into a single component saves space on the circuit board compared to using individual diodes for rectification. Small footprint. Bridge rectifiers are available in various package sizes, including surface mount and through-hole configurations, allowing designers to choose the most suitable option for their space requirements. Surface mount bridge rectifiers, in particular, have a small footprint and can be directly soldered onto the surface of the circuit board, saving valuable board space. Simplified circuit layout. The compact design of bridge rectifiers simplifies the circuit layout by reducing the number of components and connections required for rectification. This simplification streamlines the design process and helps optimize the layout for space efficiency. Integration with other components. Bridge rectifiers can be easily integrated into compact electronic devices and systems alongside other components such as capacitors, inductors, and voltage regulators. Their small size allows for efficient utilization of space within the enclosure or chassis of the device. Portable and handheld devices. In portable and handheld electronic devices where space is limited, such as smartphones, tablets, and portable audio players, the compact design of bridge rectifiers enables the efficient conversion of AC to DC power without occupying significant space or adding unnecessary bulk. Miniaturization trends. With ongoing advancements in semiconductor technology and miniaturization trends, bridge rectifiers continue to evolve towards smaller form factors while maintaining high performance and reliability. This enables their integration into increasingly compact electronic devices and systems. Overall, the compact design of bridge rectifiers makes them well-suited for applications where space efficiency is essential, allowing designers to meet size constraints without compromising on performance or reliability. High voltage and current handling capabilities are key features of bridge rectifiers, making them suitable for a wide range of applications where robustness and reliability are essential. Here's how bridge rectifiers excel in handling high voltage and current. Parallel diode configuration. Bridge rectifiers consist of 4 diodes connected in a bridge configuration. This arrangement allows for efficient handling of high currents by distributing the current among multiple diodes. By connecting diodes in parallel, the overall current carrying capacity of the rectifier is increased, enabling it to handle higher current loads. Diode characteristics. Bridge rectifiers use semiconductor diodes that are specifically designed to handle high voltage and current levels. These diodes are selected based on their voltage and current ratings to ensure reliable operation under demanding conditions. Heat dissipation. Bridge rectifiers are often equipped with heat sinks or are designed to facilitate efficient heat dissipation. High current operation can generate significant heat, and effective thermal management is crucial for maintaining the reliability and longevity of the rectifier. Heat sinks help dissipate heat away from the diodes, allowing them to operate within their safe temperature limits. Robust packaging. Bridge rectifiers are available in robust packages designed to withstand high voltage and current stresses. These packages provide electrical insulation and mechanical protection, ensuring the safety and reliability of the rectifier in harsh environments. Industrial and automotive applications. Bridge rectifiers are commonly used in industrial equipment, automotive systems, and power supplies where high voltage and current handling capabilities are required. They are capable of handling the voltage and current levels encountered in these applications without compromising performance or reliability. Overload protection. Some bridge rectifiers are equipped with built-in overload protection features such as surge current capability and reverse voltage protection. These features help safeguard the rectifier against transient voltage spikes and overcurrent conditions, enhancing its durability and longevity in high-stress environments. Reliability and longevity. Bridge rectifiers are designed for long-term reliability and durability, even under high voltage and current conditions. High-quality materials and manufacturing processes ensure that bridge rectifiers can withstand the rigors of continuous operation in demanding applications without degradation in performance. Overall, the high voltage and current handling capabilities of bridge rectifiers make them indispensable components in numerous electronic devices, power supplies, and industrial systems where robust and reliable rectification is required. One of the significant advantages of bridge rectifiers is their low cost, which contributes to their widespread use in various electronic and electrical applications. Here are several factors that contribute to their affordability. Mass production. Bridge rectifiers are mass-produced components, manufactured in large quantities by semiconductor companies and electronic component manufacturers. This high-volume production helps drive down manufacturing costs through economies of scale, making bridge rectifiers cost-effective for consumers and businesses alike. Simple design. Bridge rectifiers have a relatively simple design consisting of 4 diodes arranged in a bridge configuration. This simplicity reduces manufacturing complexity and materials costs compared to more sophisticated electronic components, contributing to lower overall production costs. Standardization. Bridge rectifiers adhere to industry-standard specifications and form factors, allowing for interchangeability and compatibility across different manufacturers and applications. Standardization simplifies the manufacturing process and reduces development costs, resulting in lower prices for consumers. Competition. The market for bridge rectifiers is highly competitive, with numerous manufacturers vying for market share. This competition drives innovation, efficiency, and cost reduction as companies strive to offer high-quality products at competitive prices to attract customers. Availability of alternatives. In addition to traditional silicon-based bridge rectifiers, alternative technologies such as Schottky bridge rectifiers and integrated rectifier modules have emerged. These alternatives offer improved performance and efficiency at competitive prices, further driving down the overall cost of bridge rectification solutions. Integration with other components. Bridge rectifiers are often integrated with other components such as capacitors and voltage regulators to form complete power supply solutions. Integration reduces the number of discrete components required in a circuit, simplifying assembly and lowering overall system costs. Global supply chains. The globalized nature of the electronics industry allows manufacturers to source components and materials from around the world, taking advantage of cost disparities between regions. This global supply chain helps reduce manufacturing costs and enables manufacturers to offer bridge rectifiers at competitive prices. Overall, the low cost of bridge rectifiers makes them an economical choice for a wide range of applications, including power supplies, battery chargers, motor drives, and consumer electronics, where cost-effectiveness is paramount. The versatility of bridge rectifiers enables their use in a wide range of applications across various industries. Here are some of the diverse applications where bridge rectifiers play a crucial role. Consumer electronics. Bridge rectifiers are essential components in power supplies for consumer electronics such as televisions, computers, audio systems, and kitchen appliances. They convert AC mains power into the DC voltage required to operate these devices reliably. Industrial equipment. Bridge rectifiers are used in industrial equipment and machinery for tasks such as motor control, power conversion, and voltage regulation. They are integral to the operation of manufacturing machinery, process control systems, and automation equipment. Power distribution. Bridge rectifiers are employed in power distribution systems to convert AC power from the utility grid into DC power for various applications. They are used in rectifier substations, traction power systems, and renewable energy installations such as solar farms and wind turbines. Telecommunications. Bridge rectifiers are utilized in telecommunications equipment and infrastructure for converting AC power into DC power to operate telecom towers, base stations, and communication networks. They ensure reliable power delivery for uninterrupted communication services. Automotive electronics. In automotive systems, bridge rectifiers are used in vehicle charging systems, alternators, and battery management systems. They convert AC power generated by the alternator into DC power to charge the battery and power onboard electronics. Renewable energy systems. Bridge rectifiers play a critical role in renewable energy systems such as solar photovoltaic, PV, panels, and wind turbines. They convert the AC output from these sources into DC power for charging batteries, powering inverters, and feeding electricity into the grid. Medical devices. Bridge rectifiers are integrated into medical devices and equipment for converting AC power from the mains into stable DC power required for operation. They are used in devices such as medical imaging equipment, patient monitors, and surgical instruments. Aviation and aerospace. Bridge rectifiers are used in aviation and aerospace applications for powering onboard electronics, communication systems, and navigation equipment. They provide reliable DC power in aircraft, satellites, and spacecraft. Lighting systems. Bridge rectifiers are employed in lighting systems, including LED drivers and fluorescent ballasts, to convert AC power into the DC voltage required to drive lighting fixtures efficiently. Consumer appliances. Bridge rectifiers are used in a variety of household appliances such as refrigerators, washing machines, air conditioners, and vacuum cleaners. They ensure reliable power conversion for efficient operation of these appliances. These diverse applications highlight the versatility and importance of bridge rectifiers in modern electronics, power systems, and industrial processes, making them indispensable components across numerous industries. These functions highlight the importance and versatility of bridge rectifiers in electronic circuits and power systems.